Hello and welcome to the Fairbanks Museum Earth Science Lab. My name is Michael and today we're going to be talking about sound waves. We're going to be doing a demonstration to help show you exactly how sound waves move through our environment and vibrate everything around us. Sound is a hard topic to discuss because the waves that create sound to us are invisible. We can't see them moving throughout our environment. We can only kind of sense them in terms of the fact that they vibrate our eardrums inside of our ear, and our brains interpret that as sound. In this experiment, we're going to kind of see what it would be like to look at our eardrums as they vibrate in our heads, right? You may have heard, especially if you know any music, if you learned how to play a musical instrument, you know that we can create different sounds depending on the frequency of the waves that we produce by making something vibrate. Whether the vibrating thing is a guitar string or the mouthpiece of a woodwind instrument. All sound and all music is made by vibrations. So today we're going to look at particularly a piece of metal here, a metal baking tray, and we're going to see how this tray vibrates when we expose it to really intense, really violent sound. So every single object around us is constantly vibrating because of the sound waves that are bouncing around everywhere, right? Even right now, this tray is vibrating very slightly, and we can't even see it, right? When I expose this tray to very high frequency, very high volume sound, it's going to vibrate, but we still won't be able to see exactly how it's vibrating. We'll see that it's moving and we can hear it shaking, but we won't be able to exactly see where it's bending and flexing. To solve that problem, we have spilled very small salt crystals all across the surface of the tray here. When we vibrate the tray, we'll be able to see exactly where the tray is vibrating because it will push the salt away from those spaces. We'll see this in action in just a second. But before we get started, this experiment that we're about to do was actually first done in the 1750s, a very long time ago, before the American Revolution, right? It was an experiment done by a man named Ernst, I have a hard time saying his last name, Kalindi, something like that. And so this machine that we're about to set up is called the Kalindi plate. You can see videos online of people who have more sophisticated Kalindi plates, and maybe if you have audio equipment at home, you could even build your own. So hopefully this will give you a good introduction to this kind of experiment. So I have a subwoofer hooked up to my computer, and I'm playing this frequency scale here. So this is just a video on YouTube. And beginning at very low frequency, you can see it slowly scales up in frequency until it gets very high. And you can actually see the difference on the screen here between this very high frequency wave that is really piercing to our ears, and back here at the beginning, comparatively a much lower frequency wave. So slowly this program is going to be ramping up the frequency, and here is the subwoofer. On top of that subwoofer is going to be our tray of salt here. Okay, so we'll begin here at the absolute lowest frequency. That's about 20 hertz. And at such a low frequency, we're not going to get much response out of the tray or out of the salt, but pretty soon, there you go. So hopefully you can already see that a pattern has formed in the salt. There are now lines. We call those nodal lines. So as the tray is vibrating, the vibrating parts of the tray are going to push the salt away. So the salt is going to gather in places where the tray is not vibrating. Those are called the nodes. There we go. So the shape just changed, correct? There we go. Okay. And it will change periodically as the hertz continue to grow. So the natural frequency for this tray is about 112 hertz. And when it hits that point, the pattern is going to change dramatically because the entire tray will be vibrating in the same way as the sound waves. We'll talk about that more in a minute. We're at 90 hertz right now. We're getting close to 112. All right, here we're at 112. I'm going to stop it here because we're at 160 hertz. And if we go too far beyond this, it'll begin to damage my ears. I don't want to do that. So, but you can see that the pattern that the salt has arranged itself into now along these two lines is much different than that more interesting looking pattern that we started out with. And the reason for that is that once we hit that 112 hertz point, that is the natural vibration frequency for this tray here. So we'll try that one more time, keeping it at 112 hertz to see more of what will happen there. Wow, so that's interesting. It seems like it all got pulled up to the top left corner there. So that must be the spot in the tray that had the least amount of vibration. But at 112, roughly 112 hertz that we have here, because it's the natural frequency of this tray, pretty much the entire tray is going to be vibrating. The vibrations of the tray are going to match the wavelength and amplitude of the sound waves that are being emitted by the subwoofer. So the whole tray is going to be shaking. That left corner, for whatever reason, must have been the part of the tray that was shaking the least. That's why all the salt went there. There's almost no salts anywhere else on the tray except for the spots that were a little bit wet. So thank you everybody for tuning into this Chladni plate demonstration. So if this was interesting to you, seeing how objects are made to vibrate by sound and even vibrate in different ways depending on the frequency of the sound, you can do this same experiment again at home if you want. If you have audio equipment like the subwoofer I was using here, you can replicate the experiment exactly using just a baking sheet and salt as I showed, or if you don't have access to something like that, you can do this just simply with a drum. If you have a drum and sprinkle salt on it and then place it over a speaker or even hit the drum in different places and see how the salt reacts and arranges itself. The simplest way to do this is if you have a small portable speaker, place it inside of a bowl and then cover that bowl with an elastic substance, maybe like the skin of a balloon or some kind of stretchy fabric. And make sure the surface is taut like a drum, and then sprinkle salt over it and turn on the speaker. You can see how this works. You can even play a song and see how the salt patterns change as the song changes. So I hope that gives you some ideas about how to experiment with sound in your own homes. So thank you again very much for watching the Fairbanks Museum Earth Science Lab today.